Okay, so in some classes we got to number 7 in 4.1. In some classes we did not. But we did not do the Try These A, so I'm going to go ahead and do that for everybody. And then if you are okay, you can skip number 7. But if you didn't get it in class, then you should still listen. So, first step, first the directions say, convert the following decimals into a fraction. So I've already started this problem, and basically I need to read what it says. If I read this properly, it says 59 hundredths. So this is 59 hundredths. In a pinch, if you cannot remember your place values, first of all, you need to practice because that's really important. But a trick is if I have 2 decimal places, then I'm going to have 2 zeros in my denominator. And then I need to go ahead and reduce if I can. In this case, nothing goes into 59 that goes into 100. So this is actually my final answer. I'm all done. This, if I read it properly, is 4 tenths. Again, if I can't remember 1 decimal place, 1 zero in the denominator. And this can reduce by 2's. So we'll start there. That will give me 2/5. And that is my final answer. Excuse me. And last, I have 235 over 1, 2, 3 zeros. So that's 235 thousandths. Now this can reduce. I'm going to go ahead and start with 5's just because they ends in 5 and ends in 0 there. So 235 divided by 5 is 47. And 1,000 divided by 5 is 200. And that is all she wrote. I cannot reduce further. So that's all for Try These A on page 48. But like I said, some classes we didn't get all the way through number 7. And this is a word problem that says, Janice says that you can remove any zeros after the decimal point before converting into a fraction unless they are between non-zero digits, which non-zero digits are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Give an example of a decimal that supports Janice's claim. How do these zeros relate to simplify the fraction? So, just as an example, here is a decimal that I could probably take off all these zeros. Really, even this one as well. I could have 0.7, and that's an equivalent decimal. And then I can go ahead and say that's 7 tenths, and I'm done. Now, the next one says, part B says, give an example of a decimal that refutes Janice's claim. How would you explain to Janice when her statement doesn't make sense? Now remember, refute is one of the words that is on our word wall and also should be in your composition book. So if you haven't written refute down, we need to talk about what that is. To refute a claim is to prove it wrong. So we need to come up with an example that proves Janice is wrong. Okay? So, like if you think of refusing to do something, you're refusing to do something that's wrong, you're refuting. So anyway, let's keep going. Let's do ones with the same number but with zeros before the 7. Now, if I got rid of all these zeros, this does not equal 0.7. So I just gave us an example that proves Janice is wrong with her zero theory. The zeros are not between non-zero digits, but they're between the decimal and the non-zero, so I cannot throw them away because this is 7 thousandths, where this is 7 tenths, and they are not the same thing. Right? They are not the same thing. So her statement doesn't make sense for zeros that appear immediately after the decimal point. That's the big mistake that Janice is making. They can only fall away if there's nothing between the non-zeros, and that's including the decimal point. So really important that you understand the difference of where that 7 lies in its value. Okay, I'll see you all in class.